Hey, we have this interesting radical on the board. We have the square root of 21 plus 7 times the square root of 8. Before we do this, there's something that we want to look at to understand this type of problem. We would like to get this inside the radical to be a perfect square. And what we want to look at is what happens, this little identity, if we have the square root of a plus the square root of b squared. Just foiling this out, we'll get a plus b plus 2 times the square root of ab. And so then we have this property that as long as we have a 2 here, what's inside the radical is two numbers. We'll assume integers. It's not always integers, but we're looking for integers, but it's going to be easier that way. That's the product is ab, but the sum is a plus b. Now, comparing this to what we have here, the problem is we don't have the 2 there, which is making this a little more difficult. So whenever that happens, what I want to do is I want to see if I can factor a 2 out of that. Now notice 8 can be written as 4 times 2. So the square root of 8 can be written like that. But then what we could do is we can break this up like square root of 4 times square root of 2, but we know the square root of 4 is just 2. So this 8 can be written as 2 square roots of 2. So let's rewrite this expression as the square root of 21 plus 7 times 2 square root of 2. And then now we still have a problem because when we multiply this out, this is 14. And we want this to be a 2, but what I'm going to do, instead of actually multiplying these together, I want to get the 7 back on the radical. So we know that 7 can actually be written, we could write 7 squared is 49, so we could write 7 as the square root of 7 squared, which is the square root of 49. Putting that back in what we have here, we're going to have 21 plus 2 times the square root of 49 times the square root of 2. But then we can multiply that together, and we're going to have 21 plus 2 times the square root of 98. And what we've done there now is now we have it in this format. We have our 2 here, so that's good. Now the next step is we want to write 98 as a product of two numbers, and then those numbers need to sum to 21. So it's pretty easy for us to get the prime factorization of 98 because we just, backing up a little bit, we know that we multiplied 49 times 2, so this is just going to be 7 squared times 2. Now, so this is harder if the prime factorization is more complicated, but because we just have this simple factorization, there's not too many different ways to get 98. If for example, if we multiplied 7 squared plus 2, which is actually 49 times 2, if we add that together, 49 plus 2, we get 51, and that's not 21, what we want there. The other possibility would be 98 times 1, but if we add 98 and 1, we get 99, and that's not 21. So then the only other possibility to get 98 is 7 times 14, and 7 plus 14 is 21. So that's going to work for our a and b value. So what that means, going back to this identity right here, is we can rewrite this as the square root of 14 plus the square root of 7 squared. And then we have a perfect square inside of the square root. So then this is just going to be the square root of 14 plus the square root of 7. And that's it. Please like and subscribe. Thank you.